Exercise 1.2 Problem 1 Division 1. Represent using Venn diagrams universal set U which is equal to 5, 6, 7, 8 up to 13, set A which is equal to 5, 8, 10, 11 and set B whose elements are 5, 6, 7, 9, 10. Okay, it's an interesting problem. Let's do the Venn diagram. Okay, so Venn diagram, basically you need to draw a rectangle and that represents the universal set. So we have set A and set B to put two circles, intersecting circles. And after that, or even before that, we'll have to see whether there is any common element between A and B. I'll tell you why we need to do. Anyway, let's check. 5. Yes, 5 is common in both these sets, A and B. And 5, 8 is not in B. 10, yes, 10 is in A as well as B. So, and then 11 is not there. So, which means A intersection B is 5 and 10. So, which means there is some common element. If, let's say, there is no common elements between these two sets, A and B, then you should draw two non-intersecting circles. See, here in this case, they are intersecting. There is a common area because we have common element. Suppose these two sets don't have common element, then we'll have to draw something like this. I'll just draw very quickly, roughly. Okay, two non-intersecting circle, and this is B. Okay, in the case where you don't have any intersection, but in this case we have intersection. So, which means we'll have to draw intersecting circles. You understand? So, these two sets are disjoint sets. There is nothing common. Okay. So, that's the reason. First, we need to check whether there is any common element. So, in this case, we have 5 and 10. So, fill that first here. So, put that in the common area. So, this is the common area between A and B. Put that 5 and 10. Then, see what are the remaining elements left in A. A, you have 8 and you have 11. So, that needs to go in this area. That is from here. Okay, let me just draw. So, this area. This is the area where you have to put the elements which are in A but not in B. Basically, this is A minus B. Okay. So, let me repeat. First, put the intersecting, the common elements between A and B, that is A intersection B. Then, put the remaining elements of A in this area. Okay. This is A minus B. This whole thing is A and this is B, right? So, what is A minus B? Whatever is in A but not in B, right? So, this is in B also. So, which means this gets removed. So, this is A minus B. Okay. So, this part is now done. Now, repeat the same thing for B. What is in B which is not in A? That is 6, 7 and 9. So, put that in this area. Okay. Right. So, 6, 7, 9. Now, you have put all these elements. What you need to check is that we will have to cover all the universal set elements and check whether they are covered. If they are covered, then we can leave it as it is. If they are not covered, it means they are the elements which are not in A and B, which means we need to put it outside of A and B. Okay, now let's check. 5, yes, it is there. 6 is there, right? 7, yes, it is there. 8 is here. 9, yes, here. 10, 11, so 12 and 13 are not here. 12 is here, no. 13 is here, it's not here. So 12 and 13 we need to put outside of these two circles, but inside the rectangle, because rectangle represents universal set. So all the elements of universal set will remain in the rectangle. Okay. And the elements which are between, if you have elements common between A and B, you'll have to draw two intersecting circles and put the common elements here. Okay, then the next step is write all the elements of A which are not in B, right? There is A minus B here, then B minus A here. And that's how the Venn diagrams have to be represented. So, key, first find out whether you have common elements. If you don't have common elements, put two non-intersecting circles and to follow the same procedure. Okay, if you have intersecting elements, you will have to put first fill the intersecting elements, then only you have to go to the other sets, okay, other areas. Okay, so I hope it's clear. Thanks for watching this video.